This is a talk that I gave yesterday on commitments and privacy in the MEV supply chain. It talks a little bit about our design for an order flow auction at Flashbots, but it's more about how we think about the MEV supply chain and how we think about keeping it specialized, keeping it permissionless, keeping it efficient. So more about sort of system design rather than our OFA specifically. And I'll move over here. If you're interested in looking on with my slides, I, like a good MEV specialist, copied James, and I have a tiny URL. So it's tinyurl.com/MEV-SC, like supply chain or smart contract, HH, like hard hat or hacker house. So let's get started. I assume at this point you all have seen the MEV supply chain like several times, so I'm not going to reintroduce the idea, but roughly this is what we would like to see in the MEV supply chain, which is to say this flat supply chain where you have specialization across many different roles within the supply chain. So if you are a validator, you don't also need to be a block builder or also need to be a searcher. You can just play the role of a validator proposing blocks to the network. And we want that because the job to be done for a validator and a builder are very different. If you are a validator, ideally, you just are able to run software off the shelf. You don't need really complicated kind of MEV searching infrastructure. You don't need the infrastructure to simulate merge bids. You don't need connections to searchers, all these things, because that would raise the bar of becoming a validator much higher compared to what it is today. So we want the supply chain that's flat. We want specialization of roles between them. And we want many different parties at every different part of the supply chain to be playing each role and them to be competing to provide value across the MEV supply chain. Lastly, we don't want any enshrined or privileged actors, so that doesn't mean flashbots. No flashbots in enshrinement, no enshrinement of any other sort of central third party in this supply chain. And the alternative is MEV dystopia, where the user, instead of interacting with this modular supply chain that's flat with many different specialized actors, is interacting with sort of one entity or a small group of entities that's vertically integrated and owns the whole stack end to end, from validating to searching and maybe even the wallet. And again, I'm kind of rushing through this because I assume you all have engaged with this content a little bit before, but we don't want this because it gives a place where censorship can be introduced, where rent can be extracted, and it's opaque and kind of breaks down a lot of the properties that we care about in public blockchains. So how do we get to MEV utopia? How do we prevent from MEV megafund black box from happening and make sure that we have this kind of modular specialized supply chain with a lot of competition in it? And the convention that we have at Flashbots is that we need to enable trustless collaboration between different parties within the MEV supply chain and allow for the maximum amount of competition to happen at every step in the way. But this is quite hard because parties don't naturally trust each other in this supply chain. And I have the example of MEV-Boost and sort of why collaboration is difficult between builders and validators in MEV-Boost. So a validator wants to propose the block that has the most profit inside of it. But again, we want this world where a validator doesn't necessarily need to have the sophisticated infrastructure to figure that out themselves. So they would like to outsource that job to a specialized party, a block builder, who has that infrastructure. But if a validator can see the builder's blocks in the clear, they can steal MEV, they can front-run users that are inside of it, right? So if you have clear text kind of sharing of builders' blocks with validators, the consequence is that builders are comfortable sharing their blocks with validators that they trust, your Lido, Rocket Pool, Coinbase, Binance, etc. of the world, and not parties like solo stakers, your small folks of the world. And this is a bad equilibrium because then you have differentials in the amount of money that are large stakers are able to make compared to solo stakers. And it's quite a bit of money. It's like 100% extra APY from using MEV-Boost. So what you should take away from this is that for these two parties to collaborate together, builders need privacy. They need their blocks not to be seen by validators before they're included on chain. So what happens if we introduce privacy into this system? If you imagine that builders are only sharing block headers, as an example, with validators. In that case, then validators have trouble trusting builders. Because builders could lie to validators about the contents of their block if they're only seeing the block header. So a builder could construct a block that's not valid. They could lie about the profit. And they could withhold block bodies too if validators do sign the header of this block. So privacy is not alone. It's your necessary condition, but it's not sufficient. Builders need privacy, but validators need commitments from builders in order to feel comfortable collaborating with builders. And the builder needs a commitment from the validator that they are actually committing to a block before they're willing to withhold the body to. So you need these dual things: first privacy, but also credible commitments. And how we address this in MEV-Boost with this protocol that uses a trusted third party called a relay. We're looking to decentralize in the future. That acts as a commitment device that both builders and validators are using, and it also helps manage privacy in sort of 3 easy steps. So first, builders build blocks, and they send them to the relay, this third party sitting in the middle of builders and validators. The relay will leak a little bit of information to validators, so they share the block header and its profit. And the validator will commit to the most profitable header that they get from a relay, and do that by signing the header and returning it to the relay. After that, the relay will reveal the block body. So it's this kind of simple 2-step commit reveal process that uses the relay as a commitment device in the middle. And why does this enable these 2 parties to work together? So sort of what are the properties that we're looking for in this, and why are they useful? So first, we have privacy. So again, builder blocks are hidden until the block header is signed, and that means that builders are comfortable with their block headers being shared with anyone, because they know that their MEV can't be stolen, users can't be front run inside of it. But validators have this guarantee, which is really interesting, around data revealing. So they know if I sign this header, the block body is actually going to be there. It's actually going to be revealed. And they have enough information. It's not kind of absolute privacy. It's selective data sharing too. So you have enough information for validators to make competent decisions to know which header to sign, but not enough to front run, this kind of interesting middle ground. And lastly, you are using, builders and validators are using this party, the relay, to commit to blocks. So first, builders by submitting blocks. Second, validators by submitting signed headers. And the net result is that any builder is comfortable submitting blocks to the system. Any validator is comfortable outsourcing blocks to it too. So you get this permissionless quality, and we keep the MEV supply chain unbundled. And we asked ourselves after the merge at Flashbots, what's the next step? What do we want to focus on next? What part of the MEV supply chain do we think needs unbundling the most? And the answer that we came to was we needed to focus on the relationship between wallets and searchers, or searchers and users too. So focus on order flow and users, and ensure that that part of the supply chain could interact trustlessly, and it didn't centralize or vertically integrate. And it's from the simple premise, users create MEV, searchers capture that MEV today. Can we create a system that lets users capture MEV instead? And it's permissionless ideally, so we further unbundled the supply chain. And the way that, or rather first, so why is that difficult? Because if users are sending their transaction in the clear to searchers, you can get front run, your transaction can be messed with in multiple different ways. But even if you trust the searcher that you're submitting your transaction to, there's no way necessarily for you to internalize that MEV, just sending a signed transaction. So you don't have bargaining power in the system. And if you do even manage to get a searcher to pay you some value in your bundle, some sort of relationship, there's no way to enforce that payment downstream the MEV supply chain. So imagine the searcher is willing to pay the user, but the builder front runs the searcher even still. So you need some way of enforcing payments even beyond the searcher-user relationship. These kind of 3 issues are making it difficult for users and searchers to collaborate. And the solution ends up looking somewhat like MEV-Boost, and it uses a lot of similar properties, which is what I want to get across to you today. We again introduced this trusted third party called the Matchmaker that both the users and searchers use to collaborate. And the user submits their transaction to the Matchmaker, who again selectively shares information with searchers, who can use that information to construct partial bundles. This is something like the Matchmaker saying, hey, a user here wants a swap on the ETHUSDC pool. I'm not going to tell you how much, Mrs. Searcher, but I'm just going to tell you there's someone that's interested in swapping on ETHUSD. And the searcher will reply with a background or intended background and say, hey, Matchmaker, please place me behind this user who's interested in the ETHUSDC pool. I don't know exactly what their transaction is, but I'm optimistically trying to backrun it with this partial bundle. The Matchmaker will fill partial bundles with the user's transaction and send it on to the builder if it extracts any MEV, with a condition that the builder needs to pay the user back the MEV that it extracts. And so again, this system uses a lot of the same kind of properties and concepts that MEV-Boost does. So it relies at the core on privacy. User transactions are hidden from searchers, which means they're comfortable with interacting with any searcher on the other end of the matchmaker. But it's not absolute privacy, it's programmable. You have selective data sharing. Just enough information is shared with searchers to help them optimize, but not too much to get front run. And finally, you're using this middle party, the matchmaker, for commitments across the MEV supply chain. So searchers are committing to certain backruns optimistically, and you're using these bundle validity conditions to ensure users are paid their MEV. And the net result, again, is this unbundling of the MEV supply chain where users are comfortable submitting their transactions and any searcher can interact with the system and extract MEV. But it's many of the same kind of concepts and ideas as MEV-Boost. This is what the MEV supply chain looks like after this is introduced. So we now have this interface between wallets and searchers, or user and searcher too. We have this interface between builders and validators that's trustless. But you have these gaps, clearly, and there's also obviously more work to be done. So in particular, I think an important gap here that we're going to be focusing on at Flashbots is the interface between a searcher and a builder. Because right now, searchers with their bundles have to trust builders not to unbundle you, not to front your MEV, and that limits the amount of places that you're comfortable sharing your order flow with. And you have the same trust assumption in MEV-Share as well, and you actually heard this earlier from Danning in sort of conversations around where to send transactions to and which builders. Ideally, we have a system where anyone is comfortable sharing a bundle with a builder, and there are no trust assumptions in that process. You have permissionless access to order flow. We call it order flow sharing at Flashbots. You can do this with SGX. We just we just announced yesterday that we have our builder inside of an SGX. We're running on Sepolia. We're lending actual blocks on the Sepolia testnet with an SGX builder, which is pretty cool. And maybe you can do it with crypto economics as well. These are all sort of potential paths for this nebulous thing that I'm calling MEV build between the searcher and builder. And there may be something also between the user and wallet, but this seems less pressing than other things downstream in the supply chain. We're also not comfortable here just introducing like more and more repeated trusted third parties in this process. Like, the intention is to build decentralized systems instead of just introducing more trusted third parties. So at Flashbots, what we're doing here is we're trying to build this decentralized platform for programmable privacy and credible commitments in the MEV supply chain that is kind of an abstract layer that allows you to express your preferences in privacy and economic commitments, both for the case of MEV-Share, MEV-Boost, eventually MEV-Build, and other parts of the MEV supply chain. That's kind of the future and how to think about that in the bigger picture of what we're doing. Hope you enjoyed the talk. We started with kind of the picture of what we want with MEV utopia and dystopia, looked at how it breaks down without trust and privacy, and how you can introduce privacy and commitments back in order to make sure that this trust isn't needed and keep it permissionless. Again, we're trying to build this decentralized system for privacy and commitments in the MEV supply chain. That's all I have for you today. I'm happy to take some questions.
Can you go back to the MEV-Share slide?
Sure.
So, how does the user know that the searcher that their transaction gets shared with doesn't, use that information? Run them with it, or.
So we have the notion of programmable privacy in this design, where the user is sending their transaction to the matchmaker with either some set privacy preferences or some reasonable defaults set by matchmaker that chooses the selective information to share with anyone who's listening. So if you're swapping on Uniswap v2, like presumably you're not going to tell the searcher what the slippage is. Maybe you'll tell them the pool, as an example.
My other thought on this, I think this isn't really your fault.
Oh boy.
Well, this feels like at the point where you're negotiating for a transaction, like negotiating it to be backrun on a DEX, something has gone wrong. Right? Yeah. Like there's value leaking all out of that whole transaction. Like it feels like these sophisticated parties should be able to trade with each other or something, right?
Yeah. So this starts from the premise of users are going to make regular transactions, and we just have to deal with those consequences because this is what our partners are telling us. But ideally, if you could have some magical signature scheme or something that wallets and users are using, that would be much better. But people nonetheless do all sorts of things that create MEV, and we have to deal with those consequences at Flashbots, unfortunately. Yeah.
Can you share a little bit more of the last step between the bundle and the condition, like decide how do you?
Yeah, this is probably the largest unknown in this design right now, to be frank. So the notion is that the matchmaker is only willing to share bundles with builders who are going to respect paying some MEV that is paid to the fee recipient, which is the builder, to a set of addresses that are attached to the bundle, which we're calling a validity condition. How this is enforced, it's either by trust, like you have some relationship with the Flashbots builder, or maybe V69 or rsync or whatever. You could put it inside of the code and run it in SGX, maybe crypto economics too. But initially, we're just assuming the trust relationship between the matchmaker and builders. Jorgos?
One other technique you can use here is that the commitment doesn't need to be enforced for that block. The builder or the searcher, whatever, they can have some bond put up somewhere. And after the transaction is landed in the next block, if that condition that was specified was not met, you can slash them. So you can say my transaction should have been fifth transaction in the block, and can add the storage to it, for example, that says my transaction was not there, so slash the builder.
Yeah.
How do you determine the size of the bond?
Sorry?
How do you determine the size of the bond?
Yeah, that's a great question.
And that you need like an extra step of
Fixed-
communication there
honestly, I'd
too.
make it fixed size. Fixed size.
MEV is not a fixed size.
Sorry?
The MEV is not a fixed size. So
I
like,
understand.
there's some.
I think the hard thing about that is how do you give a commitment for something without sharing information about it with the builder yet, So if the game is like you don't want to share the bundle with someone who's not making a commitment, then how do you get the commitment before you share the bundle? You know what I mean?
You tell me.
Yeah. Huh?
You tell me.
Open question. Yeah. What's up?
Does the matchmaker commit to any specific auction mechanism, or does he just choose? Because I imagine like you have like N user transactions
Mhm.
and F or K have like go bundles, and they might not be able to like use all of the optimal ones for all of the other optimal transactions. Then you have to commit to some like selection tier.
Yeah. Share you have something to
Well,
say?
I think one important thing to note here is the matchmaker is not actually selecting anything. It's only acting as a sort of relayer. So it's not, its job is not necessarily to pick the best combination of user transaction with searcher bundle. It's only to apply the user transaction inside the partial bundle and then forward that to the builder. So the actual auction itself, you can think of as taking place on the builder.
I guess I'm saying
And the reason for that, because it's very non-intuitive, is that builders may have some other set of information that leads to better outcomes in some cases than the matchmaker is aware of with its set of information. Like you may have some state that comes before that the matchmaker is not aware of, that leads to better execution.
like let's say one searcher submit one partial bundle.
Yeah.
That turns out to be like the best partial bundle for all user transactions. But the searcher is only willing to take one particular user transaction as part of the bundle. Then like
Matchmaker is the searcher itself.
the matchmaker is the searcher.
Is
I guess the question is then like how do you decide which one goes into it, right? Like that one gives user the best kind of welfare boost.
Yeah.
But who receives the best one, and then who gets the second?
Yeah, it's, like we're playing around with different allocation rules. So if you're interested in like writing an allocation rule for the matchmaker, I'd love to see that.
Okay, but for now, like there's
For now, the matchmaker is like designating individual transaction hashes. They're like, all right, this transaction hash corresponding to this selective data sharing is the one that I want to back.
Oh, okay, so each partial transaction corresponds to exactly one user.
Yeah.
Like the
There's, like-
matchmaker is done.
There's a way that it may work in the future, which is a searcher says like, here's an empty entry, and you can try and insert any possible transaction in this that you have access to. And I'm like interested in this kind of transaction. Like I'm only interested in transactions that touch CryptoPunks as an example. So try anything that matchmaker that touches CryptoPunks. But in V0, it's just like transaction hash. So it's more relevant in the MC entry set, and I think that's an open question. Yeah.
So in an MEV utopia, theoretically, you want to have the minimum amount of gas usage that
the maximum amount of MEV captured.
Sure.
It seems like this kind of moves a lot of the computation on chain for like optimizing a bundle, since like you're having to pre-provide the transactions that are going to be trying to be matched to transactions. So do you think that this is going to move a lot more gas usage on chain, plus the addition of having to add in a ton of more payments to even more parties in the supply chain?
Yeah, I think MEV is all about trade-offs. And I think at the moment, the trade-off of like enabling permissionless interaction between users and searchers is worth the extra gas on chain. In the long run, you'll probably have searchers co-locating their code inside of an SGX, or like using magical and NPC protocols that mean we don't have to do any of this stuff. So you'll move that computation on chain. But this certainly does like add inefficiencies that you don't have when all information is public. When all information is public, then you don't get any internalization.
We're in the,
So we'll go right to left.
in the case that there is like a cow of some sort, this design would cause the searcher to submit back-running transactions per bulk and then just profit off that spread. So, right?
Yeah.
Okay.
You probably do it otherwise if you made the matchmaker smarter. But at the moment,
Matchmaker is going to definitely stay dumb, right?
well, no, and this is just at the beginning of the design. So I would love for you to write the cow design. You had a question?
Yeah, is there an incentive for searchers to spam the matchmaker?
Yeah, absolutely.
All sorts of, and what's stopping them from optimistically trying to sandwich a transaction?
So there is an incentive, like part of the design is that you don't necessarily know exactly what the private transactions are that the matchmaker has. And so you optimistically construct a lot of things that you think the matchmaker may have access to, right? So again, like, maybe someone is trading on ETHDenver and Uniswap V2, and I'm interested in that. So construct an empty bundle and send it our way. And the matchmaker is like this highly specialized party that has software that can either handle that through something like reputation or payment or whatever. And your second question was?
What's stopping someone from optimistically trying to sandwich?
Yeah, so initially, I'm just gonna check. Oh, I thought you were raising your hand to say something. Initially, the system will probably be background only. I think in the long to medium run, we have the perspective that you can't really prevent that you can't prevent sandwiches from happening in the system. You just need to help users internalize the MEV from the sandwich. The kind of caveat that I have about that is that if you're sandwiching a user and you're just paying back all the value from the sandwich, it seems like you're losing some amount of money to the LPs that you would get by just backrunning the user and kicking back the background instead. Yeah. So I think long run, you probably can't prevent the sandwich from happening. You just have to help the user internalize on MEV. Jorgos, you had something to say?
It seems that a wallet would be likely to replicate and try to do this.
Yeah.
Do you think any wallet is willing to be a bit more ruthless than existing wallets, which have sort of been politically correct, let's say, versus this might end up becoming a bit more, you can start offering like more aggressive and make this one. Start offering it now.
Is your question like, will people integrate with this, or is your question, are they going to vertically integrate?
Like run it without opting in to Flashbots infra and doing it themselves?
I think if you wanted to do something yourself, you wouldn't design the system like this, probably. So the matchmaker is designed from this design goal of being permissionless for searchers. And that means, to Larry's point, that you're going to get spam. It's like a huge amount of load that you're going to get from searchers, like the Flashbot builder today, that you need to handle. And wallets are not in the business of running giant amounts of simulation. You run giant amounts of simulation to get permissionless searcher sets, which we think drive better user outcomes, which is why we're doing it. But if a wallet wanted to do something, then maybe you run the matchmaker with no privacy and a permission searcher set. And I wouldn't be surprised to see someone do something like that, or opt into one of the other OFA designs that has a permission searcher set or something. Yeah.
So a nice number of like things a searcher can submit into the matchmaker, since you have limitations on how much computation you can actually do.
Probably. I don't have a number for you. So, yeah. I mean, we'll have to cap it at some point. The question is, yeah.
How do you deal with like simple like searchers that are just gonna keep on adding more and more and more computation to you?
We dealt with it in the Flashbots builder with the notion of reputation. So you can, like searchers as they land bundles over time, build up reputation. And we separate searchers who have no reputation from those who do in different simulation clusters. So if we get DDoSed by a bad actor, that like takes down one simulation cluster, but all the good actors are on some other one. So how we handle it at the Flashbots builder, I think it's worth like exploring part of the payments for this instead, like having searchers submit a micropayment per bundle, something like that. There's many ways to solve this problem. You can do bonds also.
How big of a problem is DOS actually? Like, we know how to do horizontally scaling systems very well already. So what's the actual concern here?
How big of a problem is DOS? I think it's like, can you design a system where DOS is not a problem when you move to decentralized? But in practice, it was a very big problem for us in like the first 6 months of Flashbots, and not really since then.
Who is going to be operating the matchmaker?
Yours truly, and we hope you. Also, you know, the code would be open source, so and anyone can run the matchmaker. The question is just, you know, can you get users to trust you and send transactions to you, and can you get searchers to listen to the information that you're sharing in submit bundles?
So
It's probably more a question on this side than searchers.
Yeah.
So, yeah.
So it seems like it's going to be like a quite sensitive case in the flow because it has previous knowledge, like it has anticipated view of what's going to happen on the market.
Mm-hmm. Yes.
Yeah.
And that's gonna be you.
Yeah.
Huh?
And that's gonna be you.
Me personally.
But you need to use it to trust the matchmaker and the matchmaker, essentially trust the matchmaker. Otherwise, the matchmaker can take some.
Yeah. Searchers do
An extra layer of trust.
Yeah.
So would it make sense to, for example, consider that since the wallets already have this sort of position, like they already capture the user intent, like they could be like operating that part of the flow?
So we thought about that to some extent, like can you run some software locally at the wallet? And our friends have taken other design trade-offs in their systems too that look something like that. Ultimately, we decided to take different architectural trade-offs, largely because we think the matchmaker will play an increasingly complicated role that requires like specialized infrastructure, like being able to handle searcher DOSes as an example, or maybe being able to handle different allocation rules, because some users may want an MEV kickback, some users may just want the best price possible on their trade. So we think the matchmaker role is somewhat complicated. It will require specialized infrastructure, and for that reason, a specialized entity makes a little bit more sense rather than software on a like local software wallet. And the other thing to note is that this is designed with the notion that in the future it'll transition to, you know, the magical decentralized block voting network that we're creating in the future too. So this is just a job to be done by Schwab at some point in the future.
For now, this objective of this selective data sharing purely to maximize value for the user. And if that is true, if that is the case, and the way to do that would be to share all the data, would that change your guys' roadmap on what to build here?
I think to begin with, we'll probably be more permissive with the data and like use some simple heuristics on when to not share data. So as an example, like anytime someone touches Uniswap v2 or its forks, like you have to throw up a wall there and not share that information. But you know, if someone is interacting with like OpenSea, it's probably less important, right? So I think to begin with, it'll be more permissive, and over time, we'll figure out where it makes more sense to layer on privacy, with like the goal of giving users the best execution possible.
Do you think there will be a global optimum for swaps transactions on Uniswap?
What do you think?
I think yes. I think it probably looks something like 0x transaction relay RFQ style and just sharing everything, but I'm not sure. But I'm curious if that were the case, would that still require this implementation?
I'm sure you would love having everything given your place in the MEV supply chain. I don't know if our users feel the same, but you know, I would love to figure out that option.
Also, with zero X transaction unit is the meta transaction. So it's like an entirely different transaction type. And so I think like in those cases, you can feel a lot of rules.
Why do you think sharing the pool that's getting touched is the best piece of information to leak to get the benefit?
I don't know, but I think it's an example that people can grok, so I use it. But like, if you have the pool that's being touched, you don't know the direction. So it's a little bit like it raises the risk of if you're trying to front run that trade outside of the system. Is one thing, but you could construct two optimistic backruns in either direction, whether they're selling one direction or the other, and submit both to the matchmaker in that way. So I do think it's like kind of clever, but I'm not sure it's the best thing to do. We're going to figure that out.
So if you don't announce which pool your order is going to touch, then you expect the searchers to submit backgrounds for every pool.
Every pool they care about, yeah,
Interesting.
within like the parameters of how much, how many partial bundles we allow.
Shitload of simulation.
Welcome to the Flashbots builder, my friend.
Did you consider making the searcher pay the user directly instead of having to go through the builder?
Yeah.
And is there some like advantage to your mechanism with having the builder do it that I'm not looking up?
The advantage is like one, the integration is just much easier. So searchers out of the box can just pay as they do now to the fee recipient. So you don't need custom integrations, like everyone can use the contracts as they are now. It's more capital efficient that way. Two, I have this like much more hand-wavy loose notion that this is how it's going to work in the decentralized block building network, but that's like not an actual reason, it's just an intuition. So it's really just for easy integrations for searchers. That's it.
Also, the searcher would have to know the user's address to pay for it. There may be some privacy consideration.
Connecting this to the graph in Quintus talks where there's that box that's not transparent fully. Do I think of these searchers as within the box or outside of the box?
They're outside of the box.
So in the first step, every single searcher would know there's a transaction in that.
Well, actually, Quintus, what do you think?
I would say that the matchmaker is the box, and that what the computation happening, the little bots inside the box, is whatever script's being submitted, whatever code's running inside. So if it's like a bundle, it's a simulation happening there. And then, yeah, does that make sense?
No.
So I
Incredible.
I said that inside the box, you have some version, some action being taken by like someone on behalf of the searcher, from like bot or whatever.
So that's
You can think of that as the simulation happening, as the matching part inside the matchmaker. Right.
the selected data sharing part is sharing within the box.
No, that's yeah. So I guess I was simplifying a bit. That's like before the part I was talking about. Because when a searcher submits some bot to act on their behalf inside of the box, they can sort of make that bot more efficient by having an idea of what the auction will be like. That's the selected data sharing. Right? And then what this bot inside of the box is doing is whatever the matchmaker computation is doing. So it'll be like an expression here. I want to match all these kind of pools. So it's very limited.
I guess the reason I'm asking is like if the first selected data sharing part is like crossing the wall, then technically these guys can still run.
It depends what information. So that's the hard question. The question is like, how do you get sort of economic efficiency by having this operation inside of the box be conditioned on ample information without having information that is be exposed at the detriment of the user. And it need not be that simple. It doesn't have to be like, oh, I release this information, I don't release that. You can think of like very complicated scenarios where like nested boxes and all these kinds of different things. But that's like the high level integration.
I'll keep on taking questions until someone tells me not to. So are we at
I
time?
would say one more question, and also there is a whiteboard for a purpose. So if there's boxes need to be drawn, go ahead, help yourself.
One more question. So,
If you tend to like
is that conditional logic play out from the searchers, then why would you, like, instead of not sharing the direction of the trade and saying submit a map done to both directions, which can lead to like a lot of simulation, why not just allow searchers to submit sort of conditional that says that, you know, if this trade is this large, I want this background.
That's the intention too for us.
Okay.
It's like searchers submit what we call hints, which hint to us what trades, what they want where exactly. So you may say, I only want this background behind trades if it's notional size. And then you don't necessarily need to do simulation on everything. It's like a matching process. So, what's
It
up?
reminds me of like intents in fixed, like indications of interest or something in fixed protocol, where it kind of sounds like we're rediscovering fixed and how to express intentions in a somewhat cryptic way to only people that we want to problem.
It's an interesting notion. Sure. Okay, thank you so much for your interest and your questions. Feel free to talk to me about it. One last thing. We have an API that we want testing and feedback on. So if you're interested in that, talk to Shay and the Leverage. Thank you so much.